All right, part two video of the difficult questions from exam 2. So moving on to question 11. So we've got a transformation here, and you can clearly see we're going to be having transformations with matrices. So we're going from y equals log base e of x to y equals log base e to x minus 4 plus 3. Now with this second equation, to look for the transformations, you do need to have the coefficient of x being 1 inside your bracket. So just take that 2 out, and then we're going to have x minus 2 inside the brackets plus 3. Now, what the transformations, we can clearly see the transformations now. So we've had a dilation factor, of 2 from y-axis. Oh, that's terrible handwriting. We've shifted to the left, shifted to the right 2, and we've gone up 3. All right, so these are our 3 transformations. Now with matrices, you could just look at these, the last matrices, and you basically want to have 2, 3. Okay, so we've gone across to the right 2, and we've gone up 3. So we can do a process of elimination. So it's not B, C. Oh my gosh. Are we going? Okay. Well, we can just leave it there then. I'm also, just before we do that, I'm just looking at the dilation factor here is 0.5. All right, so I couldn't see transformations of logs or exponentials in your textbook, but I did find it on the internet. So just with the dilation, okay, and I do remember doing it with some functions. I can't remember which ones, so maybe they were, I just couldn't find it in the textbook. So you can see here, if we just go down to horizontal stretch or compression, so that's your dilation factor. So basically your coefficient of x is going to tell us that dilation factor, and it's just the reciprocal. So you can see for the first one, it's 1/5 times x, so it's been stretched by 5, but that's a dilation factor from the y-axis by 5, and then compressed by 1/3 means it gets, I'm doing it with my hands, but you can't see it. So we're kind of stretching it out. It's stretch or compress doesn't mean anything. It's dilation by 5 or dilation by 1/3, but stretching it means it's getting wider, and compressing it means it's getting smaller. But you can just see we've got the reciprocal for the dilation factor. So going back to this question here, I just need to change the dilation factor of 2 to 1/2. Okay, and that's how we get the 1/2 here. It was good this question though that there was only one option with 2 and 3 on there. But this question was poorly done, and I think it was poorly done because students didn't rewrite it to see the transformations that way. So that question, let me just look at my notes, 33% of students got correct. All right, question 12, another log question, although the previous one wasn't really a log one. All right, so we've got the expression log base c of a plus log base a of b plus log base b of c is equal to. So this is where you need to use your change of base rule. Okay, so we're going to change the base for all of these. Now, if you're wondering what the change of base rule is, let me just go to my textbook. Which section was it? I think it may have been this one. It's already on that one. It's funny if I was, can't remember. Okay, so there's your change of base rule in the middle. Okay, so that should be in your bound reference. So let's use that change of base rule for this question. Now the rule I just showed you, they were using A, B and X, but I might just rewrite it using A, B and C because A, B and C are used here. So we've got, I'm just copying it down. So log base A of C is equal to log base B of C over log base B. That does not look like a B. I might just write that again. Log B of A. Okay, so with this you can see you've got 1 over. All right, so on your numerator you've always got 1. So basically you want 1 for your numerators. So if we take the first one, log base C of A, notice how I've changed the base to be, or in the change of base rule, it's B. But if I had a B here as well, it would equal 1. So I'm going to change the base for this first one to be base, what am I doing? Base, it doesn't really matter which one I choose. Let's do, it has to be C or A. So I might just do log of base A. All right, so my argument, so remember in your change of base rule, the C goes up the top and the base goes on the bottom. So I'm going to have a log base A of A. So that's how we're going to get the 1. And then on the bottom, I'm going to have log base A of C. Okay, so I've got the change of base rule. You've got the bases are now the same. So because your base and your argument for the numerator are the same, it's equal to 1. And then on the bottom, I've got log base A of C. So what I want is to see that somewhere. Now I can do a process of elimination. I know that's definitely not going to be there. Probably don't need the negatives either because there's no negatives on here. And D, you'll notice you've got the base and the arguments are the same, so they would all equal 1 anyway. All right, so we're going to be choosing between A and B. So I want, first of all, to have 1. Okay, so it looks like the only possible answer is B because it's the only one that has this expression in it. Okay, so the previous one doesn't. But let's just do another one so we can practice the change of base rule. So I'm going to choose the second expression now, log base A of B. Okay, so on the top, I want to make it 1. So I'm going to do log base B over, on the bottom, we're going to have log base B of A, which is going to be 1 over log base B of A. So you can see that's your second, this one here, which is good. And I also don't have that in the first expression. They've kind of just rewritten the whole thing. Okay, so I can clearly see that that's not right. And let's just do it once more for the last one. So this time we've got log base B of C. So I'm going to do log base C of C on the top and then on the bottom log C B. All right, so that's actually a good question to have in your bound reference to practice that change of base rule because you see them pop up every now and again. Let's see if I can work out which question that is. Or if it's that one, it's 45% of students got that one correct, but I could be looking at the wrong questions at this point in time. Okay, moving on to question 13. So the inverse of, all right, so I've got this domain here. So remember that's important to know. We also can't be negative can't be negative on the bottom, so that's important. All right, they've restricted the domain because it has to be restricted. You can't take the square root of a negative number, and you also can't have on your denominator 0. So that's why -2 is not included. Okay, so the inverse, I think you can actually do this on your calculator, but you might not get it in the same form. So let's just do it by hand. All right, so remember for your inverse, you switch your x and y. Okay, so what we can do is just switch positions with the denominator and x. So I'm going to have the square root of y plus 2 is equal to 1 over x. I'm going to square both sides. So 1 squared is 1 and x squared is x squared. And then I'm going to add 2, sorry, take away 2 from both sides. So your inverse is 1 on x squared minus 2. All right, so what I can do is just cross out those that don't have that function. So the first one does, second one does, third one doesn't, neither does that one, and neither does that one. So now look at A or B. Now we do need to think about the range, because remember the range of your function is equal to the domain of its inverse. So the range of this one, all right, so I'm just going to graph it because I can't think off the top of my head, and we can use our calculator. So graph, okay, we'll get rid of that one that we had in there. All right, so I'm just sketching my original function. Okay, so we can see that we've got an asymptote there at -2, but it looks like it, so yeah, graphically it's a bit annoying to see, but that curve would actually have an asymptote at x equals -2, so that curve would actually keep going up along that asymptote. So your domain would be any positive real value, because we can't, yeah, so it can't go below the x-axis because we can't have this equal to 0. So your answer is, sorry, thinking about 10 million things at once. So it's A, because your range of f of x is any positive r. So that means your domain of your inverse. Okay, so just looking at those two. And all right, having a look at my solution. So 50% of students got that one correct. So they probably could get the inverse, and then graphing it is the best way to find the range. All right, moving on to question 14. All right, so question 14, the transformation with the rule, okay, maps the curve with the equation y equals x cubed. So when you've got transformations with matrices, you're basically reading, okay, the way matrices work is you, oh gosh, word's about to conk out on me. You multiply a row by column. So you actually end up with 4x. Okay, so 4 times x and then 0 times y. But you'll always notice the, except for an inverse, the zeros there. And then we've got the plus 1. All right, so they're not as scary as they might look. And then you can do the second row times this column. So 0 times x is 0 and -2 times y is -2y. And then we've got the plus 3. So your point x, y, or might just say x, f of x, becomes this. So what you can do is you can just say, well, let's just think about my transformations. So with the transformations here, okay, so I'm doing a few, I'm not just answering this question, I'm just giving you a little bit of theory. Oh God, It's a terrible highlighter. That's a bit better. I'll just shade it in a bit more. The 1 means that we've gone across 1, and the 3 means we've gone up 3. So even if you can't understand all of it, you should, if you have plus matrix, like we do here, identify those translations. So for these, I can have a look that we must have a +3 on the end. So I'm going to cross off any that don't have the +3. Now I can see this one has a -3 and this one has a -3. We do have a +3 as a constant here, and in A, and in B it's a part of the numerator. So I don't want to go and cross them off yet in case they've brought together a common factor. Sorry, I meant common denominator. All right, so, oops, I had to delete a few things. Let me just quickly cross them back out. So C and D. Okay, so we've got that with the shifted to the right 1, we want to have, let me just think, okay, can't be C, and remember we need to take the 4 out the front of the bracket, so it can't be B and it can't be E. So the correct answer is A. Okay, so remember when you're looking at your transformations, your coefficient of x inside the bracket must be 1 and the dilation factor outside. So if we were looking at this one here, the 4x plus 1, to look at the transformations, the 4 needs to come outside the brackets. So that means your translation was 1/4. Okay, so that's why we could cross off B and D. Obviously, that just leaves us with A. We can also look at the other transformations. So we do have a negative here, which means we've had a reflection. Okay, so there's represented there with that negative. And I'm just thinking, and then you've got a dilation factor of 4, but that would probably come when you simplify your, simplify your, what am I saying? Simplify your fraction. Okay, what you could also do, so if you didn't have like that sort of understanding of transformations, or you couldn't limit it down, remember you have changed x and y to 4x plus 1 and negative 2y plus 3. So I'm just going to go to the assessor's report because they have specifically looked at the transformation. So your image is 4x plus 1, which we had. So your point when we rearrange them is x equals x minus 1 on 4. And then they've done the same with y. And then you just substitute them into y equals x cubed. And you can see you get that. So you could do a lot of this on your calculator as well, but it's good to have an understanding of how transformations work, and you can just do a process of elimination like I did for this question. And it would have taken me a bit quicker if I didn't even do this mapping. All right, if you just looked at the translation, so the 1 and the 3, and I crossed off C and D, and then I thought about the horizontal translation, so moving across the right by 1 allowed me to eliminate 2 more, so A being the answer. And in an exam, if you can answer a question through elimination, it's probably a lot quicker than trying to do it the way that the examiner's report showed you. All right, question 15. In an orchard of 2,000 apple trees, it is found that, oh God, let's get the highlighter out. 2,000 apple trees found that 1,735 trees have a height greater than 2.8 meters. The heights are distributed normally with a mean of mu and a standard deviation of 0.2. The value of mu is closest to. All right, so let's have a look at the probability, the proportion. So x is greater than 2.8. Doesn't matter with normal distribution whether it's equal to or not. Probably should get rid of that. don't want to do the wrong thing. All right, is 1735 over 2000. All right, so what we can do is, so we know that the standard deviation is 0.2 and we want to find the mean. All right, so we're going to have to do this on our calculator. Just got to try to remember what to use. All right, I think I remember. Let me just go. I might actually pause. All right, actually, before I do it on the calculator, I just want to draw the normal distribution so you can visually see what is happening here. So the mean is always in the middle, and we want to know what the mean is, sorry. And we know that we have an area of 1,735 over 2,000. And we want to know the probability that x is greater than 2.8. Now, because this probability is quite high, 2.8 is probably to the left. So we're going to be looking at this area here being 1735 over 2000. So what we can do is use standard normal distribution. So if I go onto my calculator and we'll use the inverse normal when we know the probability, and you'll probably realize very soon whether you've chosen the wrong one. Okay, we want x to be greater than 2.8. Because it's greater, we're using the probability to the right of the point. So you can see on my diagram, see how I've shaded to the right because we want it greater than. The probability is 1735 divided by 2000. And we're just going to use the standard normal distribution for now to find the standard score. So what we have here is this is 2.8. But for the standard score, let me just get it back up, it was negative 1.115. Negative 1.115. So we can use our z-score formula, or our standard score formula, which is your value minus, I always get them mixed up, and I'll use the notation that we use in methods, not in further maths. So your value minus the mean over the standard deviation. All right, so let's put our values in. So Z being our standard score, which we just calculated, so negative 1.115. Just make sure that when you put into the calculator, you don't use the rounded version. All right, X is 2.8 minus the mean, which is what we're solving for, over the standard deviation, which is 0.2. So we just plug that all into the calculator. All right, so we can go to solve, and I'm going to drag that answer down. Equals 2.8 minus, and we don't have to use mu, we can just use x. And I should have put brackets around all that, so I'll go and do that. Otherwise, it's just going to divide the x. So make sure you use brackets or use the fraction button. And we don't want that, we want a decimal answer. So 3.023. Okay, so the correct answer for that one is A. Now, 45% of students got that one correct. I don't know whether you can do a process of elimination. Anyway, let's keep moving on. Question 16. A function f has the following two properties for all real values of theta. A possible rule for f is... Okay, so what we have is pi minus theta is equal to negative, I'm not going to use that highlighter, it's hard to see, negative f of theta, and f of theta minus 0 is equal to negative f negative theta. So basically we've got sine, cos and tan functions here, and we've got different values for the angles. Now you could go in and substitute in a different value of theta if you like, and just see what works for you. So when you're substituting it in, you're substituting for x. So first one you do sine pi minus theta, and you can let theta equal, I don't know, pi on 3 or something. All right, so if you think of the unit circle, all right, this first one, pi minus theta, we are here. So that is equal to negative f of theta. So basically we want to know which function is negative in the second quadrant, because this is showing us that it has to be negative. So the only one that is positive in the second quadrant is and the one that's positive is sine, so it could leave us with cos or tan. All right, so I can say, all right, it's not going to be A and it's not going to be D. Then the other one means that we've got still in the same quadrant, but negative f of negative theta. So we're in this quadrant now, so 0 minus theta, but that negative is showing us that it's going to make it a positive, if that makes sense. So we're in this quadrant here. Okay, so whatever is in here, sorry, I feel like I'm not making myself clear enough. In the fourth quadrant, whatever is positive becomes negative because you've got the negative in front of your function. So in the fourth quadrant, cos is positive and tan is negative. So in this quadrant here, we've got, so here we had negative cos and negative tan, basically. They're the two that are negative. Here, because our function is negative, we're going to have negative cos, and tan is already negative in the fourth quadrant, so it's going to be negative, negative tan, which is positive tan. So the only one it can be is cos. All right, so that one is just understanding the unit circle and how those values relate in each quadrant. All right, moving along. Question 17. Events A and B are mutually exclusive events of a sample space with, okay, probability of A, probability of B. Okay, probability of A and B is equal to. So what we can do here, I don't think we need to draw a two-way table because mutually exclusive events have nothing in common. Maybe have a go at it. I'm actually going to start doing it with a two-way table because visually it helps me. But perhaps you can pause and have a go on your own. No, definitely drawing the two-way table was the easiest way. So I might erase what I've done because I want to explain the process of filling in the two-way table. And it definitely helped answer this question. So, all right, quickly sketch it. All right, so they're mutually exclusive, so that means A and B have nothing in common. So you can put a 0 there, and remember all your probabilities have to add up to 1. The probability of A is P, so there's going to be a P here, and the probability of B is Q. Okay, so all of B is Q and all of A is P. Now, because there's a 0 for A and B, that means P has to go there because 0 plus P has to equal P, and there's going to be a Q here. All right, we can fill in this spot here is going to be 1 minus P, and this is going to be 1 minus Q, so they're complement. So basically in this last cell is going to be the probability of not A and not B. So I can say, well, what do I add to Q to get 1 minus P? Okay, so I need to get rid of that Q. So 1 minus P minus Q. When I add the Q up, I'm just left with 1 minus P, and you can just check with the row. So P plus 1 minus P minus Q leaves you with 1 minus Q. So our probability is 1 minus P minus Q. And you'll notice at the moment it's not one of those options, but what I can do is take that negative out as a common factor and be left with 1 minus P plus Q. So your answer is C. And let me just see if I can remember which question that was from. That was 43% of students got that one correct. Okay, so two-way tables, way to go. All right, question 18, the range of the function is. All right, so this one here, we've got, first of all, an amplitude of 2, and usually we'd use the amplitude to help us with the range, but we do have a restriction on our domain. Okay, so we're going from pi on 8 to pi on 3. So with your calculator, you can just go to, where is it? Calculation, and we want function min or max, and we want, we'll start with the min, and your expression is 2 sine 2x, and the variable is x, and we're just going to start at pi on 8, and that is included, which is great, to pi on 3. You do really need to restrict it because remember, got a set domain here. Okay, so your minimum value is at, oh, what am I doing? All right, it's at 2 sine pi on 4. They actually haven't calculated it for us, so let's just drag that down and see if they're going to calculate it. How annoying. All right, sine pi on 4, what is that? Let's just get rid of the 2 and then multiply it by 2. How come you're not giving me your exact values? Oh. Okay, I'm in degrees anyway. You're going to give it to me now? Oh, beautiful. Okay, so it's probably wasn't doing it because I was in degree mode. There we go, root 2. So our we don't know whether that's the minimum value, sorry. So let's go back and do the max. So what I can do is just highlight that, go down, and probably just change that to max. Calculation, I can do it this way and it'll just come up with F max. There we go, don't need another bracket. All right, so the maximum value is at 2. So we're going from root 2 to 2, and remember your maximum value is not included, so your answer is going to be B. Let me just double check that. Oh gosh. Actually, good example of an error, sorry. I wonder if the reason that wasn't done well is because people like me didn't think about it. So this doesn't necessarily mean it's your, the 2 doesn't necessarily mean it's your end point. So what I might go and just do with my calculator is substitute in, I'm going to take this and change that to 2x. All right, given that, I should probably graph it actually, might have been easier. Given that x equals pi on 3. So this is our end point, and it's root 3. So the square root of 3 is actually within that range, okay, if that makes sense. So the square root of 3 is less than 2 because the square root of 4 is 2. So your answer is going to be C. So that was my mistake, jumping ahead. But yeah, graphically is probably better now that I think about it. So just graphing it, might just quickly do it. 2 sine 2x. I hate it how it graphs. Oh, that's not too bad. Okay, I should have restricted my domain, so we're going to go to given that, and we're going from pi on 8 to pi on 3. So let me just get my buttons up. So that's included, but the next one's not included. So pi on 3. Okay, so we'll graph it again. Okay, there it is, very tiny. So can you see the minimum? Oh, it's really hard to see. But you can see the end points are root 2 and what was it? Root 3. But your maximum is between that. That's where the 2 has come from. Okay. So probably a bit easier to graph, although that's not the best graph. I think to change it, you can just go to zoom. You can go to zoom in. Trig doesn't always, yeah, it's a bit better. Okay, so you can kind of see the min and then the max and the end point, pi on 3, because that's not included, but that's not actually affecting our range. All right, let's move on. Question 19. So we've got a definite integral. Okay, so we've got a definite integral. We don't know what the function is, but we know that the definite integral is equal to 5. And then we've got to use that knowledge to find the second definite integral. All right, so for the second one, what we can actually do is separate it. So we can have 1, 3 to f of x dx. And then with the 3, or the negative 3, we can do that as a separate definite integral. 1 to 3, negative 3 dx. Okay, so this 2, okay, can come out at the front. And then the antiderivative, so we can just do this on the calculator, and I know I should probably do it by hand, but I'm not going to. Main. So keyboard. All right, 1, 3, and negative 3. Doesn't matter if you took that negative out the front. All right, so we get negative 6. All right, so I know that the antiderivative of f of x dx is equal to 5. So basically we're going to have 2 times 5 minus 6, which is equal to 4. So the correct answer for that one is A, and I was just looking at the wrong answer, but it was right. 49%, so not too difficult, but just being able to manipulate those definite integrals is really important. All right, 3 questions to go. The normal to the curve with the equation, now that's a 3 on 2 up there, at the point 412 is parallel to the straight line with the equation. All right, so with your calculator, you can do normals. So we're just going to, I can never remember where they are. So line, so calculation, line, and then we want a normal. And you can't see my full screen, sorry. So x to the power of, what am I doing? Power buttons down here. To the power of 3 on 2. I'm going to put that in brackets, otherwise we might make a boo-boo. 3 on 2 plus x. The variable is x, and the point is just the x coordinate, so it's going to be 4. All right, so there's my tangent equation. So y equals negative x on 4 plus 13. So plus 13, I can't remember now. Okay, is parallel. So parallel lines have the same gradient. So the gradient for this one is the coefficient of x, which is negative 1 on 4. Now, if we were doing the tangent, it's just the negative reciprocal, but we're doing the normal. So doesn't matter about the point, all we need is that gradient. So which of these equations has the same gradient? Now, if you're thinking of the gradient is just your coefficient of x, it does have to be in the form y equals mx plus c. So you can see the first one, it is in that form, it's just written around the other way. So it's y equals 4x, so your gradient is 4, so it's not going to be a. For b, I'm just going to rearrange that. So we've got 4y, take that x over, so negative x plus 7, and then when I divide by 4, we're going to have the same gradient. So let's just check the rest. C isn't because it's not negative. This one here, I know that x is going to come over as negative, but divided by negative, we're going to have a positive, and this one, no. So your only answer is B. Now, out of interest, because I didn't think that was a hard question. All right, so 48% got that one correct. All right, so normal and tangent you can do straight on your calculator. All right, question 21. Back to probability. So a soccer player is practicing her goal kicking. She has a probability of 3/5 of scoring a goal with each attempt. She has 15 attempts. The probability that the number of goals she scores is less than 7. I'm kind of thinking what has happened here. We want less than 7. This is going to be a binomial question. So n is equal to 15. P is equal to 3 on 5. We want less than 7. So this is why sometimes it's better to write out your lower and your upper limit because you might forget that we want less than 7. So your upper limit is 6. Okay, because we can't have 7. It's not 7 or less, it's less than 7, and your lower limit obviously is going to be 0. So on your calculator, so not a hard question, but they would have just made a mistake with that less than. All right, so our lower limit is 0, our upper limit is 6, our number of trials is 15, and our probability of success is 3/5. Okay, so 0.0950. Actually, I remember doing this question before and I made that error, I think. Not doing 6 instead of 7. Let me just check that answer. So 44% of students, definitely I think the mistake was with that inequality. All right, last question. The tangent at the point 1,5 on the graph of the curve y equals f of x has the equation. So this time we're given the tangent. And it's at this point. So the tangent at the point 3,8 on the curve y equals f of x minus 2 plus 3 has the equation. All right, so if we think of just the functions first of all, so we've got y equals f of x. Okay, so what has happened to f of x to get to this transformation? So we've gone from f of x to f of x minus 2 plus 3. So simple transformation, we've just gone to the right 2 and up 3. So our first tangent has gone through the point 1,5, and you'll notice that it's actually, the point follows this transformation. So if we go for x across 2, so we're going to be adding 2, and for the 5 we're going to add 3, so our new point is going to be 3,8, which is this, the second tangent goes through 3,8. Now, because the graph has the same shape and the tangent is at the same point on that curve when it's been transformed, because I'm showing you with my hands what's happening with the curve, realizing that you can't see what I'm doing. But doesn't matter what sort of curve it is. So if you want to think of it as maybe a parabola, we've had no dilation, so the parabola is kind of staying the same shape. It's just moving to the right 2 and up 3. Now the 0.15, let's say wherever it was on the graph, is still in this. If you picture the graph still in the same spot, it's just the coordinates have just changed. So what I mean is, if you've got a parabola, there's no guarantee this is a parabola, but it could be. Let's say the 0.15 was here. When your graph has shifted to the right 2 and up 5, that yellow point is still in the same spot, okay? Because your coordinates 1, 5 has shifted to 3, 8. So that means your tangent, this line, and this line, that was not as well drawn as the first one, have the same gradient. So what we can say is, okay, here's the equation of my first tangent. It has a gradient of 2. Okay, so let's do the tangent equation over here. I'm just get rid of that blue dot. Okay, so we're doing the tangent for the second equation. So tangents are straight lines, mx plus c. We know the gradient is 2, it has the same gradient, so m equals 2. It's also going through the point 3, 8, so that means x equals 3 and y equals 8. So all we've got to do is solve for c. You could leave it here, actually, do our process of elimination. So it's not going to be B or C. All right, so you've increased your probability of getting it right. But let's just substitute the values in. So we've got 8 equals 2 times 3 plus C. Okay, so C is equal to 2. So your correct answer is going to be E. Now, 49% of students got that one right. I think seeing that the transformations give you the same point on the coordinates are different, but the position of that point is the same. So your tangent is the same, and therefore the gradient of that second tangent is the same as the gradient of the first tangent. All right, girls, I'll leave it there. Some great questions there, a lot of probability, but great questions to do and understand.